Hi again. Um, did you try this question? It should be straightforward using this formula. And let's do this together. We are calculating probability of high cholesterol among never smokers. So you are using only these probabilities. So using these probabilities, or you can use the formula, then plug in these numbers and put 37.49% on top. Then you get 71.3%. So now you can compare the two probabilities. If you smoke, the probability of high cholesterol is 80.11%. But if you have never smoked, then the probability of high cholesterol is 71.3%. So from this data, you may say smoking increases the probability of high cholesterol, right? In a simple model, it's not. So like researchers do much more complicated models, but just the basic idea, key essential idea is like this, right? So we have seen two examples. Basically, they are about comparison or relationship between gender and promotion, or smoking and cholesterol, and comparing across the conditions. Now we are going to think about more general rules from the definitions. First, remember the definition of probability, a conditional probability was this. You could define the conditional probability using probabilities, and it's simply if you move the denominator to the other side, or if you multiply probability of B, probability of the condition on both sides, you will get this new formula, new equation, which means probability of A intersection B, A cap B, equals to the multiplication of these two guys. So this is called the general multiplication rule. So it holds for any pair of events. And it also has intuitive interpretation. So on the left hand side, you may understand I explained the intersection as the probability. The probability of the intersection is the probability that A and B occur at the same time, right? That's the definition of the intersection. But on the right hand side, its interpretation is very interesting. You can think it as a sequential approach. So instead of checking A and B at the same time, I first check event B. So I first ask one question. Are you a smoker or are you female? And so this is the probability that B occurs. And if B occurs, then check the probability of A. That is the conditional probability. It's the second step, so you have to update the probability using the condition. So it is only conditional on B. So like think about this. In the first, on the like simultaneous approach, you ask a candidate, are you female and promoted? And then the answer will be yes or no. That's the first simultaneous approach, asking two questions at the same time. But in the second approach, I'm asking, are you female? And if yes, then I ask, are you promoted? Yes or no. So you may split the two events sequentially, but in the end, they are the same, should be the same. It's just hypothetical approaches. And just to interpret this general multiplication rule, I gave you these more intuitive examples. And now I will show you another interesting property of conditional probability. So now try this again. You may be bored, but it's important. As I always say, more exercise is always the better. Try this and see you in the next video. It's a little bit short, but I want you to try this.